Hello everyone, welcome to this session. This is the last session of this week. And in this session, we will use a genetic algorithm to solve a real-world engineering case study. That is an antenna design problem you have seen last week, right? So remember we have talked about the dipole antenna, right? So by tuning the length and the radius of this one, and we can have different performances of the antenna. So now we will design this antenna, right? For this antenna, that the center frequency of the operating band is at 2 GHz. The design requirements are as follows. First, the magnitude of the S11 should be less than minus 10 dB within the operating band, the 1.8 to 2.2 GHz. And for L and R, each one we have a search range for here, right? Now, how to define the optimization problem? We used one method last week, right? We get the worst value of the S11 in the operating band, and we minimize this one. Now we change another way. So we can see we define such an objective function. We sample the key frequency point, and in each frequency point, we get the magnitude of S11, right, for a certain design. Then some of the frequency point, the magnitude of S11 is above minus 10 dB. We don't want that, so we will count these numbers. Then we will minimize the total number of these frequency points. So when this one becomes 0, it means all the frequency points with S11, the magnitude is below the minus 10 dB. So we can see, define such a function. So we give x and the L and R with a certain frequency range. So Fi is I is the frequency sample in the operating band. So there are total k of them. So this function, we write it here, is defined as the summing the number of frequency points with the value of the magnitude of S11 above minus 10 dB. So this is we want to minimize the total number of this, making it to be 0 ideally, right? So this function can be written like this. This one is the MATLAB antenna toolbox. So you don't need to understand this, but maybe you can see that these are the design parameters, and this is the objective function, right? So if you want to know more, you can see the MATLAB antenna toolbox, and you can also see the live streams of this function. Then we need to use GA to solve this design problem. So how to write the code? So we can write it like this. So we can first set the optimal options. These are the for plotting. We have seen it before, but here I add two more things. We define the population size to be 10 and the maximum generations to be 25. So these two, we can use them in our assignments and other case studies to set the population size and the maximum generations using this command. So you can see more in the help file of the GA function and the optimal options settings. Then we call the GA functions. So these are the design parameter search bounds. The lower bound are here, upper bound are here. So because this one, we don't have any constraints, so we leave this blank, and the nonlinear constraint blank, options follows here. So this is we call function handle two design variables. We want to output the x, right? So then we see what we will get after the optimization. So we can see this figure will show the optimization process, and with the best fitness and the mean fitness in each generation is shown here. And we can see eventually we get the objective function equals to 0. So this means that all the frequency points, we have the magnitude of S11 below minus 10 dB, right? So we can see in the optimization process, this is the operating band. We want all the frequency points, S11 is below minus 10, but here we can see at this moment, many of them are not. They are above minus 10. And when we do the optimization, we can see gradually, it arrives here. So all the frequency points sampled in the operating band are below the -10. So the optimization succeed, and you can see the live script yourself. Right. So this is a optimal design of the X, the L and R, and these are the response of the turnout as well. So then we can see if we use a FVL, we can not only see the design, we can also see the function value of the objective function at the optimal design. So we can see FVL is equal to 0 from here, right? So in this session, we have solved a design problem using the GA function, right? So that's all for this week. And then you can see the quiz and the assignments. Thank you very much. Bye-bye.